How 4 providers manage context. They can accept messages that look interchangeable, yet still need different information to continue correctly. Replaying the same saved chat can drop encrypted items, signatures, or other state a provider needs. I'm Mehrdad. We'll compare OpenAI, Anthropic, Gemini, and DeepSeek. We will not rank model quality. Instead, we'll build one portable design around their differences. Compare 5 things. Who stores the conversation history? Which hidden or signed reasoning items must survive? How can old context be reduced safely? Which unchanged opening can the provider reuse through caching? And does the request include every tool definition upfront? 2 software development kits may show the same message roles. These deeper rules decide what the application can safely own. Why do these 5 contracts matter in a real multi-agent system? Imagine a supplier exception workflow. A policy agent pulls the rule. A risk agent checks the current evidence. An approval agent prepares the decision for a human. Every handoff is a context boundary. Lose state, and the next agent repeats work or acts on an old review. Replay provider reasoning the wrong way, and the next turn can fail. Remove or summarize the wrong evidence, and the final reviewer sees a clean answer without the support behind it. Before you choose providers or models, decide what each handoff must keep, what can be rebuilt, and what only the application should own. Now lock one case. Can we approve this supplier exception? The purchasing rules, customer account, current review step, supporting evidence, and final decision must survive every handoff. That business state stays stable, while each provider adapter packages context differently. Keep the case fixed and change only the protocol. Then every provider detail answers one practical question. What must this adapter carry into the next call? If this comparison is useful, like the video and subscribe for the rest of the context management series. In OpenAI's current responses API, the application can resend earlier outputs, continue from a previous response identifier, or use a durable conversation object. Those options change how state is carried. They do not change how much attention the model gets. Older input still counts toward context and billing. If OpenAI is not storing the chat for you, keep the required output items. These can include encrypted reasoning and metadata that marks the assistant's processing phase. Compaction may return an encrypted item or an official shorter context window. Pass that provider-made state forward without changing it. Do not rewrite it as ordinary text. Prompt caching reuses an exact starting sequence. Tool search can wait to load functions or tool namespaces until they are needed. The application still owns the supplier decision, evidence, and authorization. Gemini makes this state choice clear through 2 separate API lanes. Gemini offers 2 important API paths. With Generate Content, the application rebuilds history and may create an explicit reusable context cache. The Interactions API can store each interaction and continue from its identifier. If storage is off, the client keeps the full history. It must also replay returned thought and function call steps exactly as documented. Gemini calls these encrypted markers thought signatures. They are protocol state, not readable business memory. Signature placement and caching differ between the paths. Choose the API, model, storage mode, and tool flow before you write cleanup logic. OpenAI and Gemini reveal the first design rule. Business state and protocol state need separate stores. The first pair gives the design rule. Separate what the business needs from what one provider needs. Rules, permissions, task progress, evidence references, open questions, commitments, and decisions are portable application state. Reasoning items, signatures, compaction blocks, cache identifiers, and formatting tokens are provider-specific protocol state. Keep them when the provider requires them. Do not treat them as business evidence. And do not turn one provider's private item into another provider's chat history. When providers change, rebuild the request from durable application state. Next, Anthropic shows why different cleanup steps must stay separate. Anthropic's Messages API gives several separate controls. The rules for keeping extended thinking depend on the model and tools. Prompt caching can mark a stable starting sequence, or use the current automatic caching option. Beta context editing can clear selected tool results or thinking blocks on their own. Separate beta compaction inserts a provider-made summary block when context hits a set threshold. Tool search can wait to load definitions. These operations remove different information and carry different risks. Record the required beta headers, the exact Claude model, and the behavior of the software development kit in the adapter. Keep business rules and supplier decisions outside generated summaries. DeepSeek then shows why a compatible client does not create matching behavior. DeepSeek's native thinking mode separates reasoning content from the final answer. In current DeepSeek v4 Pro examples, older reasoning is ignored on a later user turn. But reasoning inside a tool sequence must come back in full, or the native endpoint can reject the request. Using an OpenAI-compatible client library does not erase that contract. Test native endpoints, hosted gateways, and model versions separately. A self-hosted setup adds another layer. Hugging Face turns chat messages into each model's required token format. Key value caches reuse temporary attention data for the same token sequence. They do not keep durable task meaning. Track the model, tokenizer, chat format, serving engine, and cache policy as one version setup. We now have all 4 contracts. The last step is building the next request without mixing them. Now build the next request from those 2 stores. Pull only the policy, task state, evidence, tools, and recent history this call needs. Attach any continuation items required by that provider without rewriting them. Apply model settings, cache and compaction controls, then leave enough space for the answer. Count the tokens before sending. Then check the next action, not how smooth the wording sounds. Retest after any model, endpoint, software development kit, beta version, or chat format change. Own the state that matters. Adapt the protocol that changes. If this video was useful, subscribe to Multi-Agent Academy and connect with me on LinkedIn. Next, we'll show why small models need a different context strategy. I'll see you there.